recording. All right. Hello, everybody. Welcome to the beginning of week 11 of the semester. This week's a short week. We do not have class on Thursday. So we have class today, tomorrow, the next day, and then you have Thursday off this week. I did extend the due date on test 4 that was supposed to be due Friday. I extended the due date on that and then on the week 10 homework, just because there was a few issues that were going on that I wasn't able to address over the weekend because I was not at my computer. And there's only so much I can do without my computer on me. The one time that my video did not upload, I've never had it not upload before, but the one time that it didn't upload just happened to be the one time I did not have access to my computer to fix it. But it is fixed now. So Thursday's lecture, you should be able to access. Shouldn't be a problem now. But regardless, test 4 and week 10 homework, those are now due Wednesday night. So you have until Wednesday night to complete them. Please note that once you start a test, you do need to finish the test. I did not have that setting. I thought I had that setting turned on for all of the tests, but I didn't have it turned on for the previous tests. So the setting is on now. If you start a test and you stop taking it, you will not be able to access any of your homework, nor will you be able to resume the test without emailing me. So if you shut down the test to try to go do something else, that's not gonna that won't work. You're gonna get locked out of your account. You're gonna have to email me, and I will re-enable the access. But it's going to be a much more tedious process. So please make sure when you sit down to take the test that you have the time to take it. I know things happen that are outside of our control. I understand, if you're a parent and you're trying to take a test and then your kid, starts a fire in the next room and you have to abandon tests to go deal with the fire. I understand that. You just email me and I can re-enable access to you. But the purpose is of a test is for you to do the test all in one sitting, not to do it interspersively. So it does all need to be done in one setting. I should also charge my iPad because I realize it's going to die. Not die, I mean, it's just that lower battery. All right, so that's what I wanted to say there. Today, we're going to be talking about nonlinear inequalities. And this topic, I think, is really, really important if you're planning on going into calculus. If you're planning on going into calculus, nonlinear inequalities, let's see, what's a good one for this? Do a green. Nonlinear inequalities. So in calculus, you don't do nonlinear inequalities, but you do these things called sign charts. And sign charts work the exact same way that nonlinear inequalities do. So learning to do nonlinear inequalities is going to benefit you immensely in a particular section in calculus. So that's why I like to put maybe more of an emphasis on it than a traditional pre-calc class would, because it prepares you very well going into calculus. Move that around a little bit. Okay. So with nonlinear inequalities, the goal is to determine when polynomial and rational functions are positive, so their graphs above the x-axis, or negative when their graph is below the x-axis without graphing. Because we've talked about graphing before, right? So we could graph a function and tell where it's above the x-axis and where it's below the x-axis, but we want to do this without graphing. And at the bottom of this page here, this is the worksheet that I sent out, by the way. At the bottom here, you'll see a graph of this function here. This is going to be used to verify our answer. But what we are looking for when we see this inequality is we're wondering when this function is less than 0. So less than 0, that means negative. So that's below the x-axis. So looking at this picture here, we're trying to figure out where the function is negative, right? So where it is below the x-axis. So these x values. At what x values is the function below the x-axis? And the way these work is very similar to the way that we did graphing functions, where you need to make sure that everything is factored. You have to have your function factored. Because this is an inequality, we do need to move everything to one side first and then factor it. So this is kind of going to feel like a mix between graphing polynomials and solving polynomial equations. It's going to be kind of a mixture of the two concepts. What it means, by the way, and maybe I should kind of start here because we've talked about inequalities, but maybe I want to talk a little bit further about inequalities. What it means to be an answer to an inequality, right? Our answers are going to be in interval notation, so they're going to be intervals of x values that are answers. An x value is an answer to an inequality if when you plug it in, it makes a true statement. And this is something we've talked about before. But for instance, if I plug in x equals 0 to this inequality, if I plug in x equals 0, I get 0 minus 5 times 0 plus 2 quantity squared less than 0. So that's going to be negative 5 times 4. That's going to be negative 20 less than 0. That is a true statement. So x equals 0 is in the solution set. So answers to inequalities, if you remember, answers to inequalities are going to be ranges of x values. 0 is one of those values that is in the solution set, and you can check to see if a value is in the solution set by plugging it into the inequality and seeing if it makes a true statement. In this case, negative 20 is less than 0, so x equals 0 is in the solution set. Right, but we can't try every number. We just can't. There are infinitely many numbers. We cannot just plug in every number and determine whether or not this is true. Now, when I say this is true, what this does mean on the graph, it means on the graph, you're below, if you're less than 0, you're below the x-axis. So your y value is negative there. All right, it's kind of a lot of talking about the problem before doing it. We're going to be finding the intervals where this is true. Here's what we have to do. 1, move all the terms to one side and factor. One side should be 0. This is already done in this problem. Already done. One side is 0, the other side is factor. We now want to set each factor equal to 0 and find our VIPs, which are going to be our very important points. If you have a rational expression, a rational inequality, so if there's a fraction inequality, you want to underline VIPs that make the denominator equal to 0. We call those problematic VIPs. We don't have any in this problem because there's not a denominator to worry about, but we will in future problems. So I have that as part of step 2, even though there aren't any problematic VIPs in this particular problem. So we have x minus 5 times x plus 2 quantity squared less than 0. From this factor, if we set this factor equal to 0, we get x equal to 5. So this is sort of like how we solve polynomial equations. It's the opposite sign. So x minus 5 equals 0 will give you x equal to 5. X plus 2 equal to 0 is going to give you x equal to negative 2. And I'll make a note here. No problematic VIPs in this example. Problematic. No problematic VIPs in this example. We do have VIPs. We have very important points. These 2 points right here, these are my VIPs. These are my very important points. We use our very important points to set up our sign chart, right? The sign chart is the big part of nonlinear inequalities. You might think to yourself, I could just take each of these factors and set them less than 0 and solve. But that's not how it works. That's you can't just separate the polynomial into different pieces. You have to leave it as a whole, and we have to set up a sign chart. We're taking these places right here where the polynomial is equal to 0, and we're placing them on a sign chart. So they need to be in the order that they appear in. They need to be in numerical order. That's what I'm trying to say. -2 comes before 5. So I'm taking -2, putting it on my sign chart. Taking 5 and putting it on my sign chart. You do not need to plot any other numbers on your sign chart. You don't need to have 0. You don't need to have 1, 2, 3, 4, 5. You just need to take the very important points and put those values on the sign chart in numerical order. From here, we need to take test values in each of these intervals. So we have this interval here that goes from -∞ to -2. That's this interval. We have another interval that goes from -2 to 5. And then we have a third interval that goes from 5 to infinity. We need to choose test values that are within each of those intervals. So, for instance, between -∞ and -2, I could choose -3. -3 is a value within that interval. Between -2 and 5, I can choose any number I want. If I can choose 0, I like to choose 0 just because 0 is an easy number to work with. And then finally, in the interval between 5 and infinity, I'm going to choose 6. So you want to choose test values within each interval. What's really important when you're choosing these test values in these intervals is that you do not choose any of your VIPs, all right? If -2 is a VIP, -2 cannot be a test value. The test values need to be between the endpoints of their intervals. So here's the big idea. This polynomial can only change signs at the VIPs. It can only change from positive to negative or negative to positive at these VIPs because, I mean, if we look at this graph down here, the only times where it could possibly cross the x-axis are at its zeros, right? This is one of the zeros, this is the other 0. The only time that this function can possibly go from being negative to being positive or go from being positive to being negative is by crossing the x-axis. And it can only cross the x-axis at one of its zeros. Now, is it going to change sign every time it crosses the x-axis or touches the x-axis? No, like right here, it touches the x-axis and jumps back down. But the times where it can possibly change sign, where it can go from being negative to being positive, will happen at the zeros. So if we take test values within each of these intervals and we plug them in to this original polynomial, we can see what the sign of that what the sign is there. So if I plug in -3 and I get out a negative number, that means that the function is negative the entire way from -infinity to -2. So I'm going to show you how to do this in some steps here. I'm going to highlight this guy and highlight this guy here. With each of these factors, I am plugging in -3 to each of these. So I'm plugging in -3. I get -3 minus 5 times -3 plus 2 squared. So that's that first factor. This is the second factor. I get -8 times -1 squared. Here's the big trick here. All right, this is the big trick, and this is what, if you try to do it on my lab, I don't know what my lab is going to explain it to you as, but almost every book makes this a lot harder than it needs to be. Because here's the thing, I don't care that this is -8. All right, I don't care that it's -8. All I care about is at the very end, is the number that I get negative or positive? Is the number that I get negative or positive? -8 is a negative number. If you square any number, it's positive. So this -1 squared, I don't even care that it's negative. It's positive once it's squared. And a negative times a positive is a negative. A negative times a positive is a negative. So here's what it's going to look like when I do these normally. I'm not even going to plug in numbers. All right, I'm not even going to plug in numbers. I'm going to plug in the numbers, but I'm not going to care what it says. I'm only going to care if the number is positive or negative. So I'm going to be taking my test value, and I'm plugging it into each of these factors and only writing down whether or not it's positive or negative. So 0 minus 5 is a negative number. So I have a negative. 0 plus 2 squared, that's positive, because everything that's squared is positive. Right? A negative times a positive is a negative. I'm taking 6 and I'm plugging it into this first factor. 6 minus 5, that is going to be positive. 6 plus 2 squared, it doesn't matter because it's squared, it's positive. A positive times a positive is a positive. Right? Once again, you set up your sign chart using the very important points that you got from your factored polynomial. You choose test values within each of the intervals. You take the test values and you plug them into each factor, and you don't care what number you get out, you just care if the number is positive or negative. So when I plug in -3 to x minus 5, -3 minus 5 is a negative number. -3 plus 2, but then squared, positive number. A negative times a positive gives me a negative. You do that with each of the test values, and you have a setup that looks like this, where you know whether or not each of the intervals is positive or negative. You use this sign chart to solve your inequality. So if you have something less than 0, like we did on this problem, this one was less than 0, this means you're choosing the negatives. If you have whatever it is and it's greater than 0, that means that you should choose the positives. I don't like that. Let's do. So we had less than 0, so we're choosing the negatives. I'm circling these negatives. And then we are highlighting the parts of the number line that are negative. I'm going to put an open circle here, and I will talk about that in a moment. But these are the parts of the, these are the where's my pointer? These are the intervals where the function is negative. And I need to write this as an interval. I'm doing something really special here with -2. -2 is going to be excluded from our answer. -2 is going to be excluded from our answer. And the reason -2 is excluded from our answer, if you plug in -2, so let me take a note down here. Oh, just up here. Is excluded from our answer. Because when we plug in -2 to this inequality, you're going to get 0 less than 0. Which is false. 0 is not less than 0. 0 is equal to 0. So -2 is not an answer. If we had an underline on here, if instead we had it as less than or equal to, then we would have included -2 in our answer because there would have been an underline here. So 0 is less than or equal to 0. But if it's a strict inequality, we won't include -2. So writing our answer as an interval, reading it directly off of the chart, our answer is -infinity to -2 union -2 to 5. And if we're looking at this function here, which this is the function x minus 5 times x plus 2 quantity squared. I got hair in my mouth. If we look at this, this is -2 right here. This is 5. You'll notice that the function is indeed below the x-axis, touches the x-axis at -2, and then comes back up again. But it is below the, it's under the x-axis from -infinity to -2, so right here. And then additionally, it's under the x-axis between -2 and 5. This is one of those things where you probably want to see a few examples before you go too much further. There was something I wanted to write. Additionally, the other thing I wanted to point out here is I use parentheses here. I use parentheses because we had a less than sign. So if you remember back, if you have these guys, this translates to open circles, which translates to parentheses. If you have the underline on your inequality, this translates to closed circles, which translates to brackets. So that's important to remember here. So I used parentheses on my number line because I had strict inequality. So let's go ahead and do another one. So you can see what the process looks like when it's not so scattered. So here we have an inequality. We need to write this in interval. We need to write this so that, not an interval notation. We need to write this so that it is 0 on one side, and then we need to factor it. So we need to move everything to one side and then factor it. When I do that, so I'm going to subtract the 10x and I'm going to subtract the 12. So in this first step to get from here to here, I subtracted 10x on both sides and I subtracted 12 on both sides. There's a GCF I can factor out and it's 2. So I'm factoring out a 2 and I'm left with 6x squared minus 5x minus 6 less than 0. Finally, I'm going to factor this. I'm not going to show using the AC method. I don't think that's a great use of time showing how the AC method works. So I'm just going to tell you what this factors into. This would factor into 2x minus 3 times 3x plus 2 less than 0. Setting each of these factors equal to 0. So just kind of doing our little trick we have. This is going to give us x equal to 3/2. This is going to give us x equal to negative 2/3. So on my number line, I have negative 2/3 that I'm putting here. I additionally have 3/2. And just as a small note, negative 2/3 is the same thing as negative 0.67. And 3/2 is the same thing as 1.5. That's just kind of important for knowing where to put your test values. You should know what those fractions represent. I am now choosing test values. So I moved everything to one side. I've factored it completely. I found my zeros. I took my zeros and I put them in numerical order on my number line. I am now choosing test values within each of the intervals that I have. So there's negative infinity, positive infinity. So I need a number between negative infinity and negative 2/3. I'm going to choose x equal to negative 1 because negative 1 is less than negative 2/3. Between negative 2/3 and 3/2, I'm going to choose 0. And then between 3/2 and infinity, I'm going to choose 2. Okay, so I'm going to do a little bit of highlighting. Tiny bit of highlighting. Okay. I have 3 different factors here. I have 3 different factors. The first factor is this 2. And now 2 is always positive. Nothing you do with 2 is going to make 2 negative. So For the 2, I'm just going to put in a positive everywhere because 2 is always positive. There's no x to plug in. Nothing you can do will make 2 negative. Next, for the green circle, I'm taking -1, right? I'm taking -1 and I'm plugging it into this factor. And you only have to do basic minimal math in your head, all right? So plugging in -1, I get -2 minus 3. It doesn't matter that it's -5, it just matters that it's negative. So -2 minus 3 is a negative number. So I'm putting a negative here. For the pink circle, plugging in -1. -1 times 3 is -3. -3 plus 2 is -1, which is negative. 1 positive and 2 negatives, right? The 2 negatives cancel out. It gives you a positive. Once again, plugging in my test value to each of these factors. So plugging in 0, 0 minus 3 is negative. That's going to be negative. 0 plus 2, that's going to be positive. You have 1 negative, which means that this entire part is negative. Plugging in the test value 2. 2 times 2 is 4. 4 minus 3 is 1, which is positive. Plugging in 2. 3 times 2 is 6, plus 2 is 8, which is positive. 3 positives make a positive. To determine which ones we're using, we're looking right here. So it's less than 0, which means we're choosing the negatives. Now there's only one section here that's negative. It's just this section right here. There's no underline on our inequality, so we're using parentheses. And it's this section right in here. So our answer is -2/3. We're using parentheses, -2/3 to 3/2. Again, this is an interval. This is not a coordinate point. This is an interval. So what this says, one more time, is that if I plug in any number between -2/3 and 3/2, that will make this statement true. Any number between -0.67 and 1.5, when plugged into this original equation, will give me a number, will give me a true statement. If I plug in any number between -0.67 and 1.5 into this, a true statement will occur. So let's try that. Let's try doing 1, right? 1 is between, what 1 is in here? Try x equals 1, because 1 is between those numbers. Plugging into that original equation, we have 12 times 1 squared is less than 12 plus 10 times 1. So we have 12 is less than 12 plus 10, which is 22. That's a true statement. Now, if you tried to plug in any number that's not in this interval, any number not in this interval, if you plug it in, you're going to get a false statement, right? Any other number, if I plug into this, is going to give me a false statement. If I instead tried doing -1, which is outside of that interval, I'd have 12 times -1 squared less than 12 plus 10 times -1. So I'd get 12 is less than 10, 12 minus 10, which is 2. 12 less than true, false. So the only answers, the only x values that will work when I plug them into that equation are the x values between -2/3 and +3/2. Numbers like 1 that fit in that interval. Any other number like -1, which sat out here, will make a false statement. Can I answer any questions so far? We're going to do more examples. There will be more examples, but can I answer any questions so far? Let's maybe do some more. Nice refresher. Good. We're going to keep going. We're going to keep going. With this particular section, I felt very adamant about making a worksheet for it because like every second counts in this section, and I want to make sure we could do as many examples as possible. So here we have 3x cubed is greater than or equal to -15x squared. All right, so 3x cubed is greater than or equal to -15x squared. And something to point out here, and I think this is actually super important. Maybe I should have pointed it out right at the beginning. This is called nonlinear inequalities. So linear is a first power of x. So something that would be linear would be something like 2x plus 5. If it's an inequality, it would be like 2x plus 5 is less than 0. That's a linear inequality. A linear inequality, that's a first power of x, first power of x. We can solve these with algebra, no sign charts needed. All right, you just subtract the 5, and then you have x is less than -5. So you can just solve it like that. Non-linear is what needs the sign chart. Non-linear. Non-linear is going to be higher powers of x or like rational, anything that's not just the first power of x, right? Anything rational, anything with fractions, anything with polynomials, those are going to need sign charts. So this is going to be like 2x squared plus 3x minus 7 less than 0, or 3x plus 5 over x minus 1 greater than or equal to 0. Those are nonlinear, and these ones right here, that's what we're talking about today. So these types of inequalities, the ones where it's just the first power of x, those are linear inequalities, and we solve those with algebra. Okay. Nonlinear inequalities are going to be anything where it's higher powers of x or fractions, and those cannot be solved with algebra. They need to be solved with a sign chart. With a sign chart. So, getting back to this guy here. This guy, higher powers of x, so it's a nonlinear inequality. That means that we need to be able to, then we need to make a sign chart here. I'm going to add the 15x squared over to the other side. So we have 3x cubed plus 15x squared is greater than or equal to 0. So I'm adding the 15x squared to the other side so that one side is 0. The GCF here is 3x squared. So I am taking a 3x squared and factoring it out, which leaves me a 3x squared times x plus 5 greater than or equal to 0. If we take 3x squared and we set it equal to 0, you're just going to get x equal to 0. This is going to give you x equal to -5. So we have -5 and 0. Fun fact. 3x squared is always going to be positive. No matter what x value you plug into it, it's always going to be positive because it's x squared. And 3 is positive to begin with. So if you plug in a negative test value, it's not going to matter because once you square it, once you square a negative value, you're going to get a positive. So before I even choose test values, I can just go ahead and write positive on all of those because 3x squared is a squared factor. It's always going to be positive. Okay. I'm going to choose some test values now. So I'm choosing in this first interval, I'm choosing a number between negative infinity and negative 5, dealer's choice. I like to choose numbers that are as close to 0 as possible. Like the smaller the number, the better in my head. So I'm going to choose negative 6. Here's where people get messed up. All right, this is a really easy thing to do. I'm just going to point it out because it's going to happen. Negative numbers confuse the mind. They bewilder the soul. Negative numbers are what hurt people in math. I know this, you know this. If I've had one conversation a million times, it is the conversation that I did everything right except for the signs, right? The signs are always going to get you. They always have some trick they're going to throw at you. The sign charts and the negative numbers will get you because the brain thinks 6 is bigger than 5. Therefore, if I'm choosing a number less than negative 5, I want to choose like negative 4 because 4 is less than 5. But it's opposite. It is opposite with the negative numbers. All right, negative 6 is less than negative 5 because if I were making a number line, here's 0, right? It would be like negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. All right, don't let your brain trick you here. Make sure you know where your negative numbers go. Negative 6 belongs in this interval. If you do negative 4 here, your whole sign chart will get messed up. Choosing a number between negative 5 and 0, I'm going to choose negative 1. You could also choose negative 2 or negative 3 or negative 4 or negative 3.5. Any number between 0 and negative 5. Between 0 and infinity, I'm going to choose 1. Once again, I am taking the test value, and since I've already dealt with the 3x squared part, all I have to do is take my test value and plug it into this first factor. So negative 6 plus 5, that's going to be a negative. Negative 1 plus 5 is a positive. 1 plus 5 is a positive. For this first one, a positive times a negative is a negative. A positive times a positive is a positive. A positive times a positive is a positive. Am I circling the positives or the negatives in this problem? Am I circling the positives or the negatives in this problem? Positives or I see 2 people saying negatives. So it's going to be positives. So right here, if it's greater than or equal to 0, this is positives. So this would be a great time to kind of review that. So the difference of when you choose positive and when you choose negative, first of all, has nothing to do with the underline. It's all about the direction. So greater than 0, this is greater than 0, that's positives. And then in the other direction, yeah. So look at the inequality itself. To decide which one you choose, you look at the inequality itself, and then you're choosing, then you look and say, less than 0, negative, greater than 0, positive. Does that make sense to everybody? Excellent. So I'm going to choose positives, and here's where I chose the ones that were a little tricky. All right, because this looks really similar. Let me just scroll back up here. this looks really similar to what happened here. All right, what happened here, we had two intervals in a row. And when we wrote our answer, we went from negative infinity to -2, and then we went from -2 to 5. Right, and I said, hey, we're not including -2 because if we plug in -2, we get a false statement. Well, down here, my friends, down here. First of all, there's underlines, which means we're using brackets. Right, and let me just, I'll shade that part in because we're choosing this interval. I'll shade this part in. Zero is included this time. You don't exclude it, and that's because of the underline. So if I plug 0 in to this original inequality, plug x equals 0 into original inequality. So you have 3 times 0 cubed greater than or equal to -15 times 0 squared. You get 0 is greater than or equal to 0, which is true. So x equals 0 needs to be included in our answer. So we will not be excluding 0. And in fact, this is just one giant inequality all the way from -5 to infinity. So we do not separate this into two different ones. If there's an underline, we can just go straight through it, include the whole thing. Our answer is going to be bracket -5 to infinity. Now, this is probably going to be one of those things where you do need to do a bit of practicing to get these right. I'm hoping, I don't know if we'll have time to actually do any practice ones, because I want to make sure I've given you sufficient amount of examples. So I want to make sure that you have lots to look at in your notes to get you started here. Do lots of problems, and when you get them wrong, it's really important when you get them wrong, you look at what the right answer is and you figure out why your answer was not the correct one. All right, it's really, really important to not just brush it off and try again without evaluating what happened, but to look at the answer and say, why is there's 2 pieces? Or why is it 1 piece? Or why am I missing a piece? If you're confused and you can't figure out why you got an answer wrong, take a picture of your work, take a picture of the problem, send it to me. I am your instructor. I am paid to respond to your email. You are not bothering me by sending me an email asking me, why did I get this wrong? I will respond with a smile. I like to respond to these emails. Please, if you get something wrong and you don't know why, ask me. But especially on these problems, don't just brush it off when you get it wrong. Be curious, wonder why did I get it wrong, and try to figure it out yourself. And if you can't, ask me, because it is important with these ones. Otherwise, you're going to get frustrated. No problem. You will get very frustrated if you don't try to inquire, though. You'll start to think the computer is against you, and I promise it's not. I promise it's not. Okay, so that was if it was polynomial. All right, let's spice it up a little bit and let's deal with rational inequalities. Here's where we deal with problematic VIPs. All right, back at the very beginning of this, I said, underline any VIPs that would make the denominator equal to 0. These are problematic VIPs, or you can call them PVIPs. It doesn't matter what you call them. They're problematic. All right, because we cannot include in our answer anything that makes the denominator 0, even if there's an underline. If it makes the denominator 0, they are problematic and they cannot be included in the answer at any point in time. So I'm going to factor this thing. This is the difference of squares on top. So I have x plus 2, x minus 2. And then on the, oh no, on the very bottom, we have x minus 3. And the whole thing is greater than or equal to 0. So on top, we're taking each factor, and we're just doing the same thing we always have. So this is x equal to -2. This is x equal to +2. And then our problematic VIP, all right, is x equals 3. This is a problematic VIP. Problematic. Now, I, of course, cannot, after watching Bo Burnham's special, I cannot hear the word problematic without that song playing in my head. Anyone who's watched that special probably feels the same way. I cannot hear the word problematic the same way anymore. But that is a problematic VIP. So when I plot that VIP, I'm going to make sure I'm paying attention to it. So let's see, I have -2, +2, and +3. So we have -2, +2, and +3. All right, +3. Now I'm going to put a circle right here because I know I cannot include 3 in my answer, and I need to really pay attention to that. Okay, let's do a little highlighting here. Oh, every factor gets highlighted. Every factor gets highlighted. Just like this. Now, you might think like, wow, this like takes up like a bunch of space on paper, and is it really necessary? Let me tell you that this is the simplest sign chart I have been able to come up with. I have been on a journey since I started teaching to make my sign charts take up the least amount of space possible. And I swear to you, if you go online and you look at people's sign charts, and even like the book, I bet you if I take this book right here, we have Sullivan. Ooh, go see what your sign charts look like. Hold on. I can guarantee you that his sign charts are going to be nasty. Let's go find them. I think we did it before that. Nobody cares about that. Nobody cares. Where do you put? Hold on. I'm going to find this now because now I'm on a mission. Now I have to know where he put it. Cool. Yeah, it's like 2 pages. Okay. I don't know how well you can see this because like I know it's really small. Yeah, you like really can't see it at all. I can tell you his sign chart looks a lot worse. All right, you can't really tell, but it tells the interval and the number you choose, and then you have to plug that number in and actually get a number out, and then you have to write the conclusion, and he writes the word negative. This is the least amount of writing for a sign chart that I can possibly give you, and it feels like a lot, but I promise it is still the least amount possible. All right, test values. Between -infinity and -2, I'm going to choose -3. Between -2 and 2, I'm going to choose 0. Between 2 and 3, you're going to have to choose a half number. So you're going to have to choose something like 2.5. There's no other option. Any number between 2 and 3, but you can't choose 2 and you can't choose 3. And then any number greater than 3, I'm going to choose 4. So I am plugging in -3 to each of these factors. -3 plus 2 is -1, which is negative. -3 minus 2 is negative. -3 minus 3 is negative. 3 negatives make a negative. Plugging in 0 to each of these factors. 0 plus 2 is positive. 0 minus 2 is negative. 0 minus 3 is negative. 2 negatives make a positive. 2.5 plus 2 is positive. 2.5 minus 2 is going to be positive 0.5. 2.5 minus 3 is going to be negative 0.5. So that's negative. 1 negative makes a negative. Plugging in 4. 4 plus 2 is positive. 4 minus 2 is 2, which is positive. 4 minus 3 is 1, which is positive. 3 positives make a positive. What am I selecting here? Am I selecting the positives or negatives based upon my inequality? Am I taking the positives or am I taking the negatives? This one's going to be positive. So if it's greater than 0, and hey, you know, one way you could kind of look at this, if you drew like a line down here, it like looks like positive. Is that kind of cool? Is that cool? I just thought of that. I think that's pretty neat. I will unwrite that, but if it's greater than 0 here, that means you're choosing the positives. All right, so I'm choosing this part right here. There's an underline here. All right, there's an underline here. And that means that we include anything that makes the numerator 0, but we can't include anything that makes the denominator 0. So I am doing brackets here and here. And I'm including this interval, but this guy, because -3 is a problematic VIP, he gets a parenthesis because we can't include 3 in our answer. So our answer becomes, and I'll write this down in a second too. Our answer becomes -2 to 2 union 3 to infinity. And as a note, if you have strict inequalities, this means you're using parentheses on all endpoints. Means use parentheses, which are these guys. This on all endpoints. If you have an underline, why is 3 open bracket and why is it problematic? Exactly because it's in the denominator. Yes. So 3 is the parenthesis, and it is problematic. Yeah, no, you're fine. You're good. I've said open bracket before many times. It is a parenthesis because if you plug 3 in, if we took 3 and we plugged it into here, we would have 9 squared minus 4 over 3 minus 3 greater than or equal to 0. So you'd have not 9 squared, that's just 9. So you'd have 5 over 0 is greater than or equal to 0. But this number right here, this 5 over 0 is problematic because we can't divide by 0. So it can't be included in our answer. So anything in the denominator will end up with the parentheses. So if you have an underline under your bracket, if you have an underline under your inequality symbol, such as here, this means you use This means you use brackets on everything except where the denominator is 0, and I will write that down. So we should check all of our x equals before starting to determine problematic numbers. Yes. So what you're going to basically do is you're going to get to this point here, and you're going to write down all of the VIPs, and then just make note of which ones came from the denominator. So when I wrote over here that it was problematic, I wrote it in red. Whatever it takes to make a note to yourself. Make a note when you determine what your VIPs are. And the reason we do it right at the beginning before you do the sign chart is because once you get into the groove of the sign chart, you will probably forget to come back and double check that something didn't come from the denominator. If that makes any sense. Means use brackets. And points, except, will the denominator always be problematic? Yes, that is actually something I can say yes to. Yes. But very rarely am I able to say like always in math. Math doesn't like to say always. But yes, denominator zeros are always problematic, 100% of the time. No exceptions. Parentheses there. No problem. So in your inequality, if there's no underline, you're always using parentheses. All right, so if this had no underline, it would be a parenthesis here, here, and here. If there's an underline, you're using brackets everywhere except for the zeros that came from the denominator. Anything that came from the denominator is going to get a parenthesis instead, even if there's an underline. Even if there's an underline. So here's the next one. Also, are there any other questions I can answer? And Brooke, I super appreciate asking the questions. I know it takes a lot of time to type them out, so I really do appreciate you taking the time to word these questions, because I know it's not just one person that has questions, but I also know it's a lot of effort to type out math questions. So I really appreciate when you guys ask them. And I'll give you a second just to breathe and type out any questions you may have. Yes, absolutely. I want you guys to understand it before doing the homework as well. Absolutely. This next problem is a little weird. All right. This next problem, you might think, I got this under control, Professor Cook. I've got this. X equals -2, X equals 4. Let me set up my sign chart. I will be on my way. However, we need one side to be 0, and this side is not 0. So we need to subtract 1 on both sides to make it 0 on one side. So we're going to subtract 1 on both sides, and then we're going to combine to make it one fraction. So I'm subtracting 1 on both sides. less than or equal to 0. And I'm making a common denominator. That common denominator is going to be x minus 4. So this fraction would be 1 over 1. But to make a common denominator, I'm multiplying the numerator and denominator by x minus 4. So I have x plus 2 over x minus 4 minus x minus 4 over x minus 4 less than or equal to 0. They both have the same denominator now. So I can combine them into 1. I can distribute the negative. So I have x plus 2 minus x plus 4 all over x minus 4 less than or equal to 0. I even redid this worksheet to put more space for this question, and somehow I still feel like I need more space. These x's will cancel, and then you have 2 plus 4 is 6. So we have 6 over x minus 4 less than or equal to 0. I'm going to move this guy here. 6 over x minus 4 is less than or equal to 0. Okay. First of all, we have a problematic VIP right here because he came from the denominator, so he's a problematic VIP. The second thing is, what is going on with the numerator? Is x equals 6 a VIP? Is x equal to 6 of VIP? No, yeah. So like if this were x minus 6, if it were x minus 6, then 6 would be a VIP, but it's not. It's just 6. And in that case, it's nothing to us. It's nothing. It means nothing to us because this will never equal 0. 6 never equals 0. So no VIPs come from here. No VIPs. If it's just a number on top, it's just a number. Now, I will go ahead and highlight it because it's positive. It's important to keep it. It's important to put 6 on there because if it were a negative 6, if this were a negative 6, it would change things. It would change the way our chart looks. But the only number we have to plot is 4. And I'm going to put a circle here because I know that I cannot include 4 as an endpoint. I'm choosing test values. So I have x equal to 0 and x equal to 5 that I'm going to choose. And 6 is always positive. 6 is always positive. So I'm just going to put in positive signs in the numerator. Taking 0, plugging it in, 0 minus 4 is a negative. 5 minus 4 is positive. One negative makes a negative. 2 positives is going to make a positive. We wanted less than 0. That's going to be the negatives. So we're doing a parenthesis because of our problematic VIP. And that's our interval. That's our answer. We go from negative infinity to 4. And we're putting a parenthesis on him because he's a problematic VIP, because he came from the denominator. So let's do one more example. I have 7 minutes to do it. I think this should be good. Hopefully we'll be good here. Same idea as the last one, right? This is the same idea as the last one. We need to move the 2 over. That's where we need to start. So we have 2x squared plus 3x minus 4 all over x plus 1. We're subtracting 2 to make one side 0. We're going to make a common denominator. So 2 is the same thing as 2 over 1. To make sure they have the same denominator, I'm multiplying the numerator and the denominator by x plus 1. So I have 2x squared plus 3x minus 4 all over x plus 1 minus 2x plus 2 over x plus 1. They have the same denominator now. So I am able to combine them together into one fraction. So I have 2x squared plus 3x minus 4 minus 2x plus 2 all over x plus 1 less than 0. I am distributing the negative, and then I will combine together. So we have 2x squared plus 3x minus 4 minus 2x minus 2 all over x plus 1 less than or equal to 0. Combining like terms, we have 2x squared. 3x minus 2x is plus x. Negative 4 minus 2, that's minus 6. All over x plus 1 less than or equal to 0. You're just going to have to trust me on the factoring here. This factors into 2x minus 3 times, what is it? X plus 2 all over x plus 1 less than or equal to 0. Here we get x equal to 3 halves, x equal to negative 2, and then the problematic VIP from our denominator is negative 1. Problematic. So we have negative 2, negative 1, and 3 halves. Then I'm going to plot here. Oops. Negative 2. Negative 2. Negative 1 is our problematic VIP. And then we have 3 halves, which is the same thing as 1.5. I am choosing test values. So I'm going to choose negative 3, negative 1.5, 0, and 2. Taking each of these factors and we're going to plug in our test values. We're going to plug in our test values to each of these factors. So plugging in -3. -3 times 2 is -6. -6 minus 3, that's just going to be negative. -3 plus 2 is -1, which is negative. -3 plus 1 is -2, which is negative. 3 negatives make a negative. Plugging in -1.5. -1.5 times 2 is -3. -3 minus 3 is -6, which is negative. -1.5 plus 2 is positive 0.5. -1.5 plus 1 is -0.5, which is negative. 2 negatives make a positive. Plugging in 0. 0 minus 3 is negative. 0 plus 2 is positive. 0 plus 1 is positive. 1 negative makes a negative. 2 times 2 is 4. 4 minus 3 is 1, which is positive. 2 plus 2 is 4, which is positive. 2 plus 1 is 3, which is positive. 3 positives make a positive. I'm looking at the less than zeros, so I'm looking at the negatives, which are these guys here. I know I'm taking this part of the interval and this part of the interval. I need to use a parenthesis on this end because that's a problematic VIP. And then I'm looking up, there's an underline. So everything except for -1 will get brackets. So -1 had a parenthesis, everything else is going to be brackets. So if I read off my answer from the number line, I start at -infinity. I go until -2, union, and then parenthesis, -1 to 3/2. And then there's a part down here. I'll talk about that. I think I'll start off tomorrow's lecture with a talk about the last thing on this worksheet. So that is all I have for you today. I would really appreciate it if you went and tried to do a few of these problems on your homework tonight. See how they go, and then if you have trouble with one, you can email it to me ahead of time so I have it ready to go, or you can bring it to class tomorrow. And we can do it at the beginning of class. But I would really like you to try some of these to see if you're struggling, and if you're struggling, to pinpoint where it is so that we can smooth out all of the problems. Normally, I would have a day during class where we would all have a worksheet, and I would kind of like walk around and like make sure that everybody knew what they were doing. But it's a lot harder to do in this remote format. So I'd really like it if you went and tried some and then brought it back so we can talk about what any problems we're having there. Other than that, that is everything I have for you guys. Thank you guys all for being here. I appreciate all of you. I think you're all fantastic. When will this lecture be uploaded to watch? You know what? As long as my husband doesn't come in with the baby right this second, I can. Well, it takes about 10 minutes for it to process, and then as soon as it's done processing, I can get it started uploading. So I could get it done in like an hour and a half or so. But it'll definitely be done before tonight. But I could probably get it done in an hour and a half as long as I don't get interrupted by my husband. And that I will prioritize making sure that this video actually posts. No problem. All right. I think this has been asked before. Are you going to be doing any in-person classes in the next few semesters? I will not be doing any in-person classes for as long as I can, just to be home with my baby. But I will be doing a remote Math 127 next semester. So if you enjoy remote classes, I will be doing remote next semester. And any other questions? Oh, I wonder if my class is full. Hold on, let me stop the recording because I don't know. This doesn't need to be on the recording, but